take another case where the body is moving in a vertical circle, completing the vertical circle time and again. Once it has been put into motion and it completes a one vertical circle, there are no losses of energy. This will continue to move in this vertical circle till time infinity. So over here, a velocity Va is given at this point at the lowermost position. Let's say the radius is r. This is moving in a circle, this continues to move in this circle. We are asked what is the tension when this reaches angle theta. Now we have to find the tension in the string. So the very first thing is, first of all, we can apply conservation of mechanical energy principle, that is mechanical energy at A is equal to mechanical energy at B. Mechanical energy at A is equal to mechanical energy at B position. When we find the mechanical energy at A, obviously H is equal to 0. This is the reference level we are taking it as. H is equal to 0. And from here to here, you know very well that is how to find this H when theta is given. So this is going to be, if you say this is R, so this is R cos theta. So this is R cos theta plus R, that is going to be equal to H. We have done it. If there is any confusion, you can once again refer to that, how we have found the height at the various instances. So VA, if VA is given over here, then using the conservation of mechanical energy between this and this point, that is MEA is equal to MEB, that is mg 0 over here. If we use over here, it means P at A plus kinetic energy at A, potential at B plus kinetic energy at B. Potential at A, that is mgh 0 plus half mVA square is equal to potential at B, that is mgh, h you can easily calculate, plus half mVB square. So over here, VA is given, H you have found out in terms of theta. Suppose theta is 30 degree, so this will come out to be R cos 30. R value is also given, so there you are going to have some numerical values. So using this, you have found VB. Once VB is found, we can easily find AC is equal to V square upon R. Once centripetal acceleration is found, we can also calculate centripetal force as mv square upon R. Once centripetal acceleration is known, now we look out the forces which are along the radius and which can meet the requirement of centripetal force. So one is, obviously, the tension is always towards center. We are drawing this, we are taking this as free body. There is other force also, that is mg. mg is this way. Let's remove VB for time being. So mg is this way. So now there are two forces, one is T, the other is mg. So T and mg, they are the two real forces which in combination will meet the requirement of centripetal force. Now this T is already aligned along the radius. So we will not break into components. This is not aligned along the radius. So we'll break this force mg into components. Mg is always vertical. So now we see that is this and this, there are two lines. This line is cutting these two parallel lines. If this is angle theta, alternative opposite angle, so this is theta. So if this is mg, it has two components. One is mg cos theta this way along the radius. The other is this way, that is mg sin theta. So mg can be broken into two components. One is along the radius, the other is tangent to this circle. Now towards along the radius there are two forces. T is also there, mg cos theta is also there, and both of them, they are helping each other, that is they are towards center. So it means this and this component T plus mg cos theta, they meet the requirement. Requirement is what? mv square upon R. They will meet the requirement, and from here you can find the value of tension. And what does this force it does? This is obviously a tangential force. If this is a tangential force, this is pulling it this way. That is, it will accelerating it this way, and if this particle is moving in this direction, this will be reducing the speed. In terms of dynamics, we can say if there is a force, then this is what? Tangential force. Then tangential force is equal to mass into action tangential is equal to mg sin theta. Get cancelled. So A tangential is equal to g sin theta in this direction. Body is moving in this direction, force is in this direction, acceleration in this direction. So it will be retarding in this direction. So it means its speed will be gradually be reducing because the force is tangential forces in this direction. So we have A tangential in this direction, centripetal acceleration is in this direction. We can find the net resultant acceleration also, we can find it by vector sum of A centripetal and A tangential. Had this body been over here, then what could have been the case? Then T would be here. Suppose this angle is alpha, then mg will be acting in this direction. So this and this line is parallel. So this and this line is parallel. This line is cutting these two lines. So this is alpha. So components, T will not have components. T is already along the radius. So we'll break mg into components. One will be over here. That is mg cos alpha along the radius. The other will be here. That is mg sin alpha. So now over here, when it is coming from here to here, in terms of that is how we have understood the principle of conservation of mechanical energy. We understand that as it is coming down, the height is being lost, potential energy is lost, then obviously the kinetic energy will be gained. That is, velocity or speed will be gained. The other is in terms of force. If we understand, that is, now this force is acting this way. Velocity is also acting. Velocity is also in this direction. Speed is also in this direction. And this mg sin alpha, this is once again a tangential force. Tangential force is also supporting it. So obviously, when it is coming this way, this is supporting it, this will produce accretion, that is tangential in this direction. As a result, the speed will also be increasing, and in this case, we can also find the A net or tension